Hi boys and girls, welcome to a new IGCSE Physics video. In this video we'll talk about paper 6 and I'll take the specimen paper for examination from 2016 as an example, and these 12 areas will be focused in this video. Notice that these are not all the areas you will be seeing in the paper. There are some still areas will be missed here, but pay attention to these 12 main areas before you go for the real actual IGCSE paper 6 exam. Before we start, I should say that I recommend you to do this paper by yourself because the specimen paper will be very similar to the actual exam paper. So you should do it by yourself first and watch this video afterwards. So let's get started. Okay, so the first one here is about the moment, and it's a very typical question you can see. Let's look at the information given by the questions. So if you read all these lines, I'm not going to read every single word for you, but the main points here, you should be able to highlight the words 90 cm mark here. So you may want to write down 690 cm over here, and also mass M is 40, so I'll write 40 gram here. You should always try to do this marking on the diagram whenever it's given, and so that both sides are balanced surely. And this procedure is repeated for a range of masses. So as you can see, there are different masses: 40, 50, 60, 70, 80 gram here. And this is a pivot, so this pivot is this pivot. Okay. Moving on, if you look at part A, asks you to fill in a table, very typical one. So for this column, obviously you are going to fill in according to the measurement here. So take out your ruler. You don't actually need ruler here. What you need to do is to read here, and you can see this mass is huge. It's not a point. So what you need to do is you have to take the middle of this mass. So basically you may want to point here, or even better way is if you can try to draw a line or straight line here. Well, I can't do a ruler here. So you draw a line and then you read by yourself, and same for the other. So you can read much easier in this case. And so lastly, you can fill in the table and you can find these are the distance, and also for the right hand side of the table you can find 1 over d. The main tricky thing is to maintain the significance figure the same, especially when you're filling in the result table. So in this case, if the first one 40, the d is according to the marking scheme, it is 30.0 cm. The next one 24.2, 19.8, 17.2, 15.0. Remember that even it is perfectly 30 or 50 cm, you still need to fill in 0.0 in this case, because for the ruler you can see here, this is 25, this is 30, and each division, say here obviously is 1 cm. Am I right? 26, 27, 8, 9, 30, right? So 1 cm here, and 1 cm you have 5 division here, so each division reads you 0.2 cm, and therefore your reading should also be in 1 decimal place in this case, right? So even 30 you should write 30.0. And for 1 over d value, since what you calculate here is having 3 SF, so the answer should also be 3 SF. Say for 24.2, for d, when you have the 1 over d, you should do 1 over 24.2. The answer on your calculator will be 0.041322 something. So what you should do is you should take 3 SF in this case, or actually the marking scheme said at least 2, but 3 is better because here you said you have 2, you have 3 SF here. So 0, you should write 0.0413 in this case on the table. Next part will be about the difficulties and some like precaution and errors that you can say. So look at the points given is 2 points. So make sure you describe. So describe and also how you can improve. So 1 point for describe, 1 point for how. So very simply here in this case, the possible solution could be difficulty in balancing, but I probably prefer the case that you can also feel that when you are reading the measurement here, it's not that easy that you can find the perfect measurement here. So I would more prefer the second one. The marks is really hard to read, and the way to do it would be, for me, I would more prefer the taking the average for the reading. So you need to repeat a few times and take the average. The others are also sensible, but I prefer this more. Part C, the graph. When you see the graph, you should feel extremely happy, because whenever you see a graph, it's something very typical. So in this case, whenever you see a graph, what you do is firstly you draw the axis with a ruler. So draw a straight line. I don't have a ruler here. Straight line. Second thing you want to do is to label them. So M over G here, 1 over D, and also 1 over CM here. Alright, and the next thing is also the most important thing, is to determine the interval of your graph. So since you want to try to put all the dots within your whole graph, because if you remember, one of the criteria is you must make sure the graph having more than the half of the graph paper. So in this case, if you look at the table in part A again, you will see for mg starting from 40, it will be up to 80. So what you can do, well, actually you can do something like this instead. All right, and also so say here 40, 50, 60, 70, 80, 40, 50, 60, 70, 80. All right, so you don't need to start from 0. And also for 1 over D, after your calculation, assuming you take 3SF and everything is correct, you will find the smallest number is 0.0333 for 40. So for 81, it will be 0.0667. Let me write here, because I can't show the numbers at the same time. So that means you want to start from here, which is about, say, how about this? This is 0.02, 03, 4, 5, 6. Oh, so I can't actually do that. So how about I change it to, I should change it to 3. 0.04, 0.05, 0.06, and 0.07. So I can include every point here. So say the first one, 0.03. So it should be roughly about, since here's 10, right? So 0.03 is 1, 2, 3. So here for 40. And also for, well, of course you can do the middle one. I'll do the last one, 0.0667. So for 80, 1, 2, 3, 4, 5, 6, 7. So a bit more over here. All right, and I assume the middle one should be roughly like this. All right, of course you should do precisely according to your table. And lastly, don't forget to draw the line of best fit. And what it means is you have to draw a line which will balance the point and show the trend here with a ruler. Like this one is perfectly a bad example. Alright, because this, and this dots are all under the line, so this is not a line of best fit. Also, like this one is not a good one. So what you usually do is you get say some of the point above the line, some of point, like say one point above the line and 1 point below the line. This could be a good example. Alright. In this case, since we have used the broken line here, so you don't actually need to connect back to the origin here. Depends. Sometimes if you see the trend should be having when there is no m, the 1/d should be, if it should be 0, then you should connect it back to origin. But in this question, it doesn't need to do that. So this will be good enough. Part D, determine the graph gradient. Again, you should be laughing when you see this because again, it is very typical. But many people will overlook this if you don't study for paper 6 because they always say that you have to show clearly on your graph that to find the gradient g. So what you do is to go back to your graph, and okay, that's what I do, and you're going to determine. Let me use the black color. Determine the gradient. So what you do is, one thing you should not do is to take one of the points, say here, and use them as the point to determine the gradient. This is wrong. What you should do is look at your line of best fit, the blue line here, and say I will find the point for this one, and also the point, well, just choose an easy one, say this one. Alright, and what you should draw on the graph is, since you need to show clearly on the graph, so what you do is, again, use your ruler, draw a straight line, but I would prefer you to draw a dotted line here with a triangle here, just to show that you know how to calculate the gradient by using this method, which is called a triangle method. I'm sure that you do a lot in maths, but they don't actually, their marker don't actually assume you to do maths very well. So just show them you master these skills. So for the gradient, simply you should go back to part D, and you can calculate from this point should be, well, actually you don't need to draw, but let me write it here. The point for this one would be 0.069 and 80, and for this point it will be 0.032, I think, for 40. So just using this point and this point with, of course, the gradient, calculating gradient method, that means slope in maths is y1 minus y2 over x1 minus x2. So using this, substituting, you'll find the gradient. Again, since the SF here is 2SF in this case, same for this one, and also the mass. So what you do for calculating the gradient will also be 2SF. Do not do too many SF. And also, some people may also overlook and also being very lazy that when you find the gradient, you only use part of it. Say you only use this part of the line to find the gradient. And remember that the marking scheme, IGCSE authority require you to use basically the whole line. The minimum requirement is half of the line, but usually you use 80% of the line will be the safest. For part E, there's not much thing you can do. If you get part D wrong, then probably your part E is also wrong. But say if your part D is correct, getting the capital letter G correctly, what you should do is basically apply the equation provided by them. So just write mu equal the answer you take back over 40.0. Don't forget to write 0 here. Just copy what you see. And notice that this contains 3SF. And if your answer here contains 2SF, then your answer at last here will be 2SF. If luckily your gradient has 3SF in this case and 3SF here, then you will be using 3SF at last. Just maintaining the significant figure consistent all the time. So we have gone through the first 4 points here: SF, experimental errors and improvement, plotting graphs, and determining the graph gradient using the triangle method. So these are very typical one, and I'm sure that you will see it in the actual exam. Moving on, in the question 2, a student investigating the cooling of a test tube with water inside. So you read it yourself. I assume you have done it already. Part A, very easy. Just make sure you read correctly, carefully. I'm sure you're okay. Just remember that, look at this theta out here. There's no unit here, so look at the picture. It's degrees Celsius, which also write degrees Celsius at last, no matter how many degrees you see. If it is Fahrenheit or Kelvin, just follow what you see. Part B, the student pour hot water, about 2/3 of the water, and places thermometer, measure initial temperature, and immediately start the stopwatch. Suggest one precaution that student takes to make sure her temperature reading is as accurate as possible. So just imagine you are doing this experiment. If your room temperature thermometer is reading like 20 something, and immediately you put it inside and so-called the hot water, surely, well, in fact, you should not immediately start the stopwatch, because the thermometer would need some time to rises its temperature reading over here. So I'm pretty sure that the answer you should, well, mainly you should write should be wait the thermometer to be same to read the same temperature as the hot water before you start the stopwatch. Let's look at the answer. So the answer could be right, wait thermometer to read stop rising. Eye level of the mercury. Well, this is something that more general, but I prefer the first one. Stir water would maybe okay, but yeah, I think the two above would be better than stir the water. Part C, record blah blah blah, and wrap the cotton wool insulation and repeat the procedures again. Something you should highlight would be 30 seconds, every 30 seconds, and also wrap the insulation and ask you to complete the table. Right, very typical. Next page, so fill in audits. So very simply 30, and also well, all the time onwards. So 30, 60, 90, 120, 150. I'm sure you don't need to use your calculator. However, it's not done yet. Don't, every time you see the table, don't overlook the column. So right here is time units will be second. Here obviously, since the thermometer you use is in degrees Celsius, so degrees Celsius here. Even the brightest students in our class would usually overlook this, and you know, these are some easy points you secure, so don't forget that. So next part D, it asks you to compare the result and stating which experiment the cooling is more rapid. That means which one will be cooled down faster. Explain your answer with reference, of course, with the data above and relevant science. So you look at this table without cotton wool and with cotton wool. The one on the left hand side is always having lower temperature than the right hand side one. Right? Notice that the initial temperature is not the same, which may affect a little bit of the fairness of the experiment, but you can determine by yourself. This time 1 degree Celsius I think is fine, but say if the initial temperature is totally not the same, say 10 degrees Celsius, then I don't think the result is acceptable. But usually in paper 6 they don't give you such condition. So in part D, it asks you whether you think the experiment cooling, like which one is more rapid. So of course the one without the cotton wool will be more rapid. So that's the first point. Alright, more rapid will be the first point. And since you can see there are 3 points, right? So the evidence will be saying, oh, the temperature is always larger in the second one. So that's some evidence. So first point, your stand. Second point, your evidence. Lastly, since it said any relevant science, right? So you just say because, cotton is a good insulator, and then it blocks something with use the word conduction, or even say you don't support the result here, saying this is having not much difference. What you can do is saying the temperature are very similar to the other one, saying that because other than conduction there's still convection and radiation happening in the case. So the result is not very convincing. So things like that is really up to you how you explain, and there is no definite stand most of the time. Sometimes it's maybe one side, but sometimes you can choose either side. Both works depending on how you explain them. Part E, discuss the quality of the result, suggest two improvement which will allow more certain conclusion to be drawn. So obviously the quality of results is terrible, is bad, because the difference, remember to explain, because the difference here is actually not very big, say 51 and 54. It's not a huge difference. So the quality is bad because that's the reason. For improvement, so you need to write 2. So 1 and 2, you better write, you use letter to show them. So say 1 and 2. So think about how you can make difference more obvious in this case. So say the initial temperature is higher, then of course the cooling effect will be more significant in this case, and therefore the insulation would taking a bigger role. So increasing the initial temperature would be very useful. Another one would be just think about how you can make cotton wool to do more protection on the heat. So basically you use a thicker wool, say like that, so for better insulation. Oops. Alright, so these are for me that's the most the first 2 things that come up with my mind. So of course there are some other answer you can write too. Say, let's look at the answer. Will be in increasing temperature, initial temperature, ensure they are identical, use a lid. That's correct, because to prevent the convection, right? Stir to eliminate the difference between the top and bottom, again convection, thicker insulation, more sensitive thermometer. So things like that, but I'm pretty sure the 2 that I mentioned would be the most common one. Okay, let's move on. Part F. It's being carried by students in many different countries or different locations, obviously, using this identical apparatus. So don't pick on the apparatus problem. State 2 differences in the condition in various laboratories that may lead to differences in the result. So basically, by the location, it must be the temperature itself, or the wind or humidity, about the weather basically, since the apparatus are the same. So temperature, wind, and also temperature of the hot water source, maybe different water, but if you got to write 2, of course you write room temperature and also wind speed, or maybe humidity. I don't think anyone would think of the water source itself. Part G, estimate the volume of water that in the test tube can hold. So in this question, in IGCSE Physics paper 6, sometimes they have certain these kind of questions which you can find no trace at all. You have no trace at all where you can find the answers. It's not comprehension, it's not something about your technical knowledge. This question like this is actually about your common sense, about how you get familiar with the lab, whether you do a lot of lab or you pay attention to the different numerical numbers, numerical values of like the daily life things that you have. So in this case, look at the marking scheme is at 5 to 50 cm cube, which is a big tolerance, I would say. And of course, you are not going to write something like 100 cm cube, because 100 cm cube is more like a beaker size. Beaker is usually range from smallest one maybe 20 cm cube. 100 is like a medium one. A huge one is almost like 1 liter or even 2 liter. But of course, there's no way you can memorize it. But I think guessing roughly, precisely, well, try your best to guess precisely, is the only way to do. It happens to you all that I think there was a paper that you have done before asking you, say, the pressure of a person standing on the floor. So let me write here, pressure a standing person will have, which equal, as you remember the equation, F equal F over A, and say a normal person, right, standing on the floor, say 70 kg. So the force is weight 70 times 10. Area will determined by your foot. So just look at your own foot. So say around 7 cm times 25 cm. So yeah, over 100. If you want to change it back to a meter, 100 square, because 7 over 125 over 100. And the answer would, well, using your calculator to find answer, and the unit will be in Newton per meter square in this case. So using this, you can roughly guess how much, pressure, or depend. I say I also remember the thickness of the paper as well. So you may want to do something like this. Well, whatever with the equipment you have on that day. Moving on, question 3 about the circuit. So for circuit, surely most of the time you will be asked to draw a diagram, usually voltmeter, but also sometimes you will be asked to draw the rheostat. That means the variable resistor, or even more like something like a thermistor, or the light dependent resistor. So make sure you check the circuit symbol at the back of your textbook or the worksheet I provided to you before. So in this case, part A, you are going to measure the potential difference, of course, across the lamp. So what you do is to draw simply on here V. Alright, for since you're measuring the lamp across, so parallel. For ammeter will be A, and remember this is in series. Well, yeah, these are some basic knowledge you are required to know. For part B, moving on, you can see that it asks you to read the voltmeter on here, and then the L is 0.200 meter, which given a table to you. So you fill in this, simply check the unit. Oh, this time they provide you a unit, so it's fine. Part C, student repeats using different range of values. So as you can see, 246X and 1.0 with different voltage here. Use the result to predict how the relationship of increasing the length affects the brightness of the lamp. So you can tell, since you know the brightness depending on, since you have measured V as the voltage across the lamp, so higher voltage will be brighter, right? And therefore you can see that with longer L, larger L, you can have less V, and therefore the relationship is, it's like that. Part D, the student suggests the potential difference V across the lamp is directly proportional. This is the most important word, obviously. Directly proportional means, in case you don't remember, is is meaning that V versus length L. So V and L is directly proportional. So V increase, L increase. And obviously part C already have done by yourself that you can tell they're actually not in directly proportion. So directly means A increase with B, while this in this case not. This is called inversely proportion. And basically I think these are the only two relationships you see in IGCSE. So directly and inversely proportional. Or the third case would probably be no relationship at all. I think simply more likely will be only these three cases. I don't think you see any quadratic equation or relationship here. So don't freak out and just look at your answer. Part E suggests a practical reason why repeating the readings may be slightly different from those recorded on table 3.1. So that means if the student repeats the experiment, the result measurement may not be the same. And obviously this is not human error because it only says slightly different, and remember human error is always not acceptable in the paper 6. So because it's practical reason, right? So what usually you need to recall for circuit is, remember the heating effect in the circuit is determined by the power equation P equal I square R. So whenever there is current passing through, the more current you pass through, the more heating effect. That means the power loss in the cables, in the connecting wires. So this could be the reason why there is power loss, because the temperature is different every time. That's the first thing I will think of. So when temperature increase, the heating effect is more vigorous because the current will also increase. So that's why the measurement will also be different. And apart from that, different answers could also be saying, say L, when you measure them, is you want to measure 0.8 meter. But remember, this is a normal ruler. Is not like any like every measurement they have certain accuracy, right? So in this case, maybe the actual distance of L is 0.82 meter, or maybe 0.78 meter, 0.79 meter, which at last you can record is 0.8 meter because of the accuracy of your ruler. So every time you are not achieving the same exact distance, and therefore resulting in different voltage. So you can write this for question E in this case. Part F. State one safety precaution that you would take carrying out this experiment. Keywords: safety precaution, not precaution. So some of you may write precaution and you think it's something like measurement, how you make precise measurement. Then you may write the word parallax, which is wrong. I mean, in this question, this is wrong. Parallax, if you forget what parallax means, is what it means is when you look at the measurement, say this is a ruler and this is the length you want to measure, like this is a point, your eye should be in the same level, not from the above or below. But in this case, this is not something about safety, right? Safety is something affecting your life, damaging your body. So if you look at the answer, that you can tell that is not touching the wire or short circuit. You know, the second one, do not connect the terminal with the wire, something like that, is saying do not short circuit, basically. So this is something about your safety instead. So pay attention to the wording of the question. Okay, finally, last question. Question 4. Using a plastic bottle tip over in class, plan an experiment. You can see many lines, so it's a long essay you are going to write. Investigate how the quantity of water affects the stability of the bottle. So the quantity of water affecting stability. So independence variable and dependence variable here. Plastic bottle hold up to 2 liter, 2000 cm cube, and the height of 42 cm. Just highlight them or underline them. Write a plan for the experiment, including apparatus you need, instruction, that means procedures, value you use for quantity of water, how you make sure your result is accurate as possible, the graph you plot from your results. So basically they already give you the guideline here, and apparatus in this case, what you need to, well, firstly, what you need to remember is the basic knowledge itself. Some people thought that paper 6 is something about experiment, practical. You don't need to revise that much of physics before you come and just know these techniques. This is actually wrong concept and wrong attitude as well. Before you come for paper 6, you should also go through every single equation that you learn in the syllabus, although it's not as deep as paper for the long question, but sometimes you still need that. In this case, in this question, questions 4 here, what you need to remember is about the CG itself. When it's passing through the the corner of the object, say this point where the reaction force is given to the bottle, it will start when it's beyond the tipping point, it will tip over, right? So that's the angle you need to look for. That's the angle you need to look at in this case. So this one is an angle. So in case you don't actually know the question, you can try to look at part B as well, because part B is asking you measure. Sometimes they put it as part A, sometimes they put it as part B. So sometimes it's quite beneficial to read the whole question, I mean all the parts, before you start to do. So measure the angle through which bottle has been tilted. So what it means is, something I want to remind you is to bring the projector, because sometimes you see questions like this which requires you to measure the angle. So in this case, I think I won't go too deep into this, but pretty obviously you're going to measure the angles when it's about to tip over with different amounts of water. As you can see, this is the independent variable, so highlighting this is very useful. If you look at the marking scheme, you see all these things. I think it's self-explanatory, so I'm not going through this with you. For the graph, similarly, you are going to plot with different amounts of water and the angles, the relationship between these two. Something you can consider as well is, because you're not really doing the experiments by yourself, don't feel so redundant that you are going to repeat and take the average result from the experiment. So in this case, if I were you, I would say I would take about 10 to 20 measurements. So since you have 2000 capacity of the bottle, so what I'll be doing is I will do maybe 100, 200, 300, and up to 2000 cm cube. So 20 measurement in total, and of course you're not doing like 2000 times, but I think 220 is quite reasonable. And you can see that the marking scheme say 5, but anyway, you don't need really to do 20 times in reality, right? So let's write like a larger quantity will be better. And of course evenly spaced. Lastly, I also want to address you one more thing about taking the average. It's not shown in this paper, but I somehow recall from my memory that, remember, sometimes they ask you to measure, like give you a diagram, say a circle, alright, and they ask you to measure the diameter, right, and take the average of the result. So remember that for those questions, you need to draw it out, say this one, and then you say you measure, say this is 7.2 cm, and you draw another line, say this is 7.3 cm, and what you do at last, since you are taking the average, right, So 7.3 plus 7.2 over 2 equals 7.25 cm. In this case, showing them you take the average, but not just write down 7.2 or 7.3. Okay, lastly, let's go through all these areas again. So first thing is most typically is the significance figure has to be maintained all the time, especially when you fill in the result table. You also need to look at the given result by the question paper itself as well. So you need to match with their own results given to you. Also, when you do a calculation, the answers will also follow the previous answers' significance figures. Secondly, the experimental errors and improvement. I can't list all the things here to you, but just try to look and find all those paper 6 that you have done before, and you'll find most likely the improvement and experimental errors are usually like that, and also precaution as well. Thirdly, the plotting graphs. Don't forget to label and select good interval so that the graph at last will be falling in more than half the graph paper. Line or best are pretty much you know how to do that. Point 4 usually is the most overlooked one, is to determine the gradient from the graph. Remember to draw the triangle and use more than half of the line. Point 6, don't forget when you're filling in the result table, don't forget the unit as well. Always check the unit. Even the question didn't ask you to do so, do it. Point 7, rough idea of the numerical values. Well, you can't really prepare that, but if you have extra time, or if you want to be more well prepared, bring a longer ruler or even a soft ruler to the examination will be quite useful. Point 8, circuit diagram. Remember to revise and go through all the circuit diagram, the symbol itself, before you go for the actual exam, and you know how they behave as well. Point 9, correlation. That means the positive correlation, negative correlation, or what we call the directly proportional and inversely proportional. There's nothing called indirect proportional, so just inversely proportional in this case, or no relationship at all. 10, basic knowledge and equation. Remember, you need to know some basic knowledge like this one, right? The CG, or sometimes they ask you to say the lens. Remember, they ask you to draw the image of the object after the convex lens. So maybe it's like diminished and inverted, something like this. So it's about your basic knowledge that you learn from the syllabus itself. It's not about the experiment or equation. Sometimes you will use that. Measurement. Make sure you bring the protractor and bring a proper ruler. Try to use a clean one. Sometimes I find your ruler is quite dirty, and the marking is almost worn out. So bring a new transparent, if possible, ruler for you, and also protractor as well. Make sure you know how to use your protractor, and of course don't forget your calculator too. Lastly, taking the average. Make sure you show them clearly you really did take the average. Alright, so good luck for your paper 6. If you have any question, you can still ask me, but again, anyway, you make sure you read the paper 6 you have done before and see the common mistake you make. I'll see you guys next time.